Hi, welcome to Petra Dot. And today's lesson we are going to be talking about variables and types. So I'm going to break this lesson into four core parts, which is variables, variable type, variable name. Let's go with name first. Variable types, variable declaration. All right, so let's take it one after the other. If we're able to complete these four items, then you should be able to understand variable very well. What is a variable? Variable is just a container used to hold values. In the computer, it is just a memory that is used to hold a particular value. So let's use, for example, a real life scenario. A cup is a variable that is used to hold liquid. So automatically, cup is a variable. So that is the way it is in computer. Whenever you're writing a program, you are going to be using variable almost in everything you do, because computer programs deal with data, and this data is stored in the memory. And the only way to hold this data is by declaring variables that is used to hold those data, or call it values. So that is it. So now, and to declare a variable normally in Java, before you can use a variable, it has to be declared. And to declare it, we have two parts of it, which is the type and the name of the variable. Hence, this will take us to understand what variable name is. Variable name is what you use to refer to a variable that you've declared. So when they mean to declare a variable is, you say this variable, I need a variable that will be able to hold liquid. And what I will call that variable is a cup. That is the name. Every variable name in Java is meant to be meaningful. It must be meaningful. This is important because the type of naming you give to your variables, classes, and methods improves the documentation of your code as a software engineer that knows what he or she is doing, right? So if, for example, you have a variable that is meant to hold the name of a player, but you named it sum, automatically it's no longer meaningful, because you are confusing the next engineer that will continue to maintain that project, and also confusing yourself. So if, for example, that this variable is going to hold name of a player, so what you can say is to call the variable name of player, or name of player. This makes it a very meaningful name. And there are acceptable ways of naming your variable. One, let's go with unacceptable ones. Invalid names are something like, you start a variable with a number, a digit. No, it's wrong. For example, one player is an invalid name, or adding a space in between a variable name. For example, sum of numbers, this is an invalid name. Or trying to start a variable name with a character, for example, plus or star. No, you don't do this. A special character, sorry. So you don't do that. To have a valid variable name, it can start with an underscore. Fine, this is a valid variable name. And it can end with a number. For example, player 1 is better, instead of saying one player. right? And if it's going to have more than one words, they are all meant to join together. For example, sum of numbers, or you use an underscore just like we used here to separate each of them. So these are valid variable names, while these are examples of invalid variable names. So, and they are meant to be meaningful. All right, and that is all about variable name. So variable type, since we have specified, talked about this name, now the next thing is, what are these type we are talking about? Now in Java, we have what we call the primitive types. But before that, what is type talking about? Just like the name, type is saying what kind or type of value should this variable hold. So anything you define here saying is the type of value, value that this variable hold, is exactly what you can only assign to this. If you assign any other this thing different from the type you declared, the program is going to throw a compile error. Yes, Java is very, very strict on that. If you define a variable to be holding liquid, then you cannot pour sand into it. So we have example of primitives, which include one, we have the byte. So then we have two, we have the short, we have three, integer, int, then four, long, then five, we have floats, six, we have double, seven, so seven, double, we have, but okay, I've listed floats, double, then we have character, then 8, we have boolean. Now let's start from the first four. The first four, so that I'll get the understanding gradually, clearly. All right, the first four are all whole numbers. They are all whole numbers. The only difference is they have a range of value they can hold, which, for example, this is from -1 to 8, sorry, 1 to 8 to 1 to 7. But before I continue with this, let me explain something. Normally the computer understands only binary digits, zeros and ones, which is the machine language. And these zeros and ones, any of them is what we call a bit, which is the smallest unit of data that a computer can hold. Yes, so a single zero is called a bit, and a single one is also called a bit. So now each data you store in the computer, is represented in the form of bits, combination of bits. And at this point, byte, whenever you declare a byte and pass a value of byte, you're automatically requesting for 8 bits of memory space. Yes, you are requesting for 8 bits of memory space. But if you are declaring a short, you are telling the computer, give me a 16 bits of memory space where I can save the data I'm going to pass in this short, in this variable. Then if you are declaring integer, you are saying, computer, please provide me with 32 bits of memory space where I can store my whole number. If it is long, you are telling the computer to give you a 64 bits of memory space that you use to store this whole number. That is exactly what is the difference among all this stuff. Let's bring it to a real world scenario. We have 5 liters gallon container, we have 10 liters container, and we have 50 liters. So what it means is 5 liters container cannot hold any content that is above 5 liter. Even 5.1 cannot be held. Immediately it passes 5 liters, you should be requesting for 10 liters can to hold it. That is what it means. So if, for example, you declare a variable and call it byte, you can't pass the value of short to it. If immediately it crosses 127, you get a compile time error. Let's give for example. So why giving the example, I will use the opportunity to explain variable declaration. Sorry, assignment, declaration and assignment. So to declare a variable, using this example now, byte, first of all, you state the type as we said. Remember we said you state the type and the name. So we state the type and then now we'll give it a name. What do we want to hold? We want to hold a number. So I can say byte number is equals to 1, 2, 3. You can see everything is held well. It is not showing any error. It means this can hold it. And it can hold 1 to 5. It can hold 1 to 7. But immediately I make it a single digit above 1 to 7, it throws an error. It underlines it's an error, showing that this container cannot hold 1 to 8 because it is of type byte, right? But if I bring it out to 1 to 7, it works. Let's take it back to 1 to 8. Sorry, this is, let me do this so you get it clearly. This is variable declaration. Let's assign it under number is equals to 1 to 8, and we are having an error. So let's declare another variable called short. Since the short is higher than this, I will drop the range of each of these variables on the description section. So just check the description section and you see the range of the value for short, integer and long. But let's declare a short and see a short number 2. Then let's assign the value, the same value to number 2 and see. Number 2 is equals to 1 to 8. You can see that short held it without throwing an error, meaning that since we are going to hold anything more than a byte capacity, we can use a short. But if we know that our number is going to grow, probably we can just define integer or a long, because num3, because integer can even hold, sorry, num3 is equals to, integer can even hold as big as this and there is no error. You understand? So let's take this to 1 to 7. Let's take it back to 1 to 7. So all right, that is about bytes, short, int. And if you define long, for example, long number 4. So number 4 is equals to, you can see this one can even hold larger ones. What did I do here? Okay, this is higher, but later we'll talk of the bigger integer. But for now, this is, we are going to stop in this particular variable type. So this can hold more than what int can hold. So long is as twice as integer. It's a very big number. So I will share the range for each of them are on the description section. Now let's talk of the float. Float and double are similar. What do? They hold real numbers, and when we say real numbers are numbers with decimal places, numbers with decimal points. An example of them is 2.5, 45 point this. These are examples of float and double. But if you are going to define a float, then you must add an f to the end of it. Reason being that by default, Java sees a decimal number, any decimal number, no matter how small it is, as a double. So, but if you want to define it as a float means you have to pass f to it. Let's give for example, define a float number 5. Say number 5 is equal to 4.5. You see it's going to throw an error because it's seen it as a double. You provided double, but it's requiring float. That's what you are saying. So you say this variable requires type float, but you provided double. So to make it a float, you have to pass f at the end. And to define a double, you don't need to pass anything. All you just to do is say number 6 equals to 6 point, and it will throw no error. Everything goes fine. All right. Now let's talk of characters. Characters are just single digits. Any single digit is a character. Yes. Example, asterisk is a character. Y is a character. K is a character. 6 is a character. These are examples of characters. So any single digit at all, or letter, or special character is a character, right? So, and in Java, to define a character, you use the keyword character. So character is equal to a. Now when you are defining or assigning the value of a character, you must pass it to be inside a single quote, not a double quote. Immediately you do this, is no more a character, it becomes a string, and we'll explain string now. So a character is something like this. This is a valid character, or it is just a number inside, or is an asterisk inside. They are all valid characters, right? So now boolean is meant to hold a type of value that is either true or false. Yes, booleans are used mostly whenever you have any logical operations to do. So that is where boolean comes in, to check if a value is true or it is a false. So if it is met, you go ahead with your action. So now to declare a boolean is a boy. This is a valid name. Is a boy is equals to true. That is the only type of value you can have. Or is a boy is equals to false. But you cannot do is a boy is equals to John. You can't do this. Or you do something like is a boy is equals to Andrew. You can't do this because it's not an integer. It's not a string. Or you come and do is a boy is equals to 6. No. So it can only hold either a true or a false. And this is all about the primitive data type. But there is one particular non-primitive data type, an object, that we need to discuss. Just like we are supposed to discuss objects in the future, but we cannot skip this at the moment because this is a type of already defined variable, but it is an object on its own. And that data type is what we call the string. Let's put this one as 9. String is just a combination of characters. So more than one character is called a string. For example, you see these three things here. Immediately I make it this way. I bring them together as star y k 6. Automatically is no longer just one. They are not on their own. They become a string. And a string must be bounded in double quotes because it's no longer one character. It's now more than one character. So it becomes a string and must be in between double quotes. So to define a string is the only type of object that variable that starts with a capital letter. If you watch, other types are all in small letter throughout, in lowercase, whereas the first letter of string starts with a capital letter. So if you are defining it, you must define it this way. String name of player. So to assign the value, name of player is equals to James. Yes, and that is how you define your object. So let's say for example we want to print any of this our character, any of this our variable. You can use your system dot out dot print line. Remember we said we are using this method. We use this method to print out any value to console, and now say name of player, and automatically if you run this program right now, you are going to see the name of a player printed on the console, right? You see it's showing James here. You can see, let me zoom it more. So when I run it, you see that it's showing James. So if I print another one, for example, system dot out dot print line, let's say for example I want to print is a boy, is a boy. So let me use the print here. I will explain the difference later. So is a boy, and then print line. So you now pass the value of is a boy here. Alright, let's see when we run this, what is it going to be like? Let's run and see. You see the value here is saying that is a boy is equals to 4. So we have successfully created a variable and we have run it, we have printed it on the console. You can see that here I am calling the name of the variable, not the value itself, and here I'm calling the name of the variable too and not the value, and it's returning me a result on the console. So to recap all we did, what we just discussed in this lesson, we learned about variables and their types, how to declare a variable, how to assign the value of a variable, and different primitive types that we have, and the special type of variable objects that we have in Java. So if you have any confusion or any question, do well to use the comment section, and I will answer your question and do justice to that. Thank you so much. Don't forget to like and subscribe.